Today we're going to be making a PIR, passive infrared operated traffic light. PIR is a motion sensor. When it detects motion, we're going to move through a sequence of green, yellow, and red traffic lights using LEDs, and then we'll reset. So the first thing we're going to talk about today, light emitting diodes, LEDs. We talked about them previously in an earlier class, but we're going to go a little more into detail about them. So we're using three different kinds of LEDs for this one. We have a green, a yellow, and a red. So we're going to talk about how we get those different colors out of an LED. We already know how it produces light, but we're going to discuss how we get these different colors. So the first thing we need to talk about with this is the electromagnetic spectrum. All electromagnetic energy is out there on different wavelengths, so we get, depending on the length of the wave, we have different kinds of energies, starting from radio waves down this end that are 10 to the third meters long for each time it goes through the wave, all the way down to gamma rays, the smallest of rays, that are 10 to the negative 12th meters long, getting down to the atomic level in size there. Right in the middle of this is our visible spectrum. We're talking in nanometers here. So now we've just kind of zoomed in on the visible spectrum. We've got our blue down at the 450 end down here, up to our reds up here. If we go right off the end on the left side, we're getting into ultraviolet light. Up on the right side is our infrared light. So we can see the different wavelengths that our LED emits is what's going to give it its color. So right around in this 525 nanometer region, if we're given a 525 nanometers, we're going to have a green LED, about a 575 for our yellow, and right around 650 for a red LED. And also important to note, a little further up in this way in the infrared is about 850 nanometers. That is the infrared wavelength that the human body is giving off, and that's important when we're talking about our passive infrared detector. So to start discussing the passive infrared detector, you may be familiar with these. They're used in motion sensors in an alarm system, or sometimes if you're walking into a store or something and it sets off a little bell for someone coming in, that might be a passive infrared sensor. The way it is here is what you'd see in an alarm system. You're normally going to see it in the top right corner up by the ceiling of a room. You may even have them in your school, or they may be a dome shape sitting on the ceiling. But what we're going to talk about is a little bit different today. This is the same concept, it's just a small little package that we can use directly on a breadboard. Up in the top here, this white thing is our Fresnel lens, and we're going to discuss that a little bit later. And then we have three leads at the bottom down here. The first one is the positive voltage. That's our 5 volts that we're going to put into it to power the whole thing, because this is actually an entire little circuit running through this board, and we're going to power it with 5 volts. Our middle pin is the voltage out. That's what is going to send out a signal that we're going to read with our Arduino. And then the final pin is going to get hooked up to the ground. And the way this works is when it's triggered, it sends out a 5 volt signal from that middle pin, and then we can read it on our Arduino. And when it's off, it's going to send out no signal. Underneath that Fresnel lens is this little chip, this middle part here, this little rectangle. This is called a pyroelectric sensor. And what it does is when it receives an electromagnetic wave in about that 850 nanometer wavelength that we discussed earlier, like the human body gives off, it's going to energize that, and it's going to give off a small electrical signal, and the rest of the circuit's going to amplify that signal and put it out at about 5 volts out through that middle pin to our circuit. Now we're going to go back and talk about our Fresnel lens, which is over the top of that pyroelectric sensor, this white dome. What that does is it takes energy from a large area and it focuses it down onto that little square underneath. And here's kind of a little diagram showing that. We have all of our energy coming in, all our electromagnetic energy coming in here, and it focuses it down to this small little point here that is our pyroelectric sensor. And that allows us to use just this small little device, but we can cover an entire room and see if anyone or anything is moving in that room, and then set off our sensor. So at this point, we're ready to actually start building up our circuit. We start out with kind of the basic components. We've got our 9-volt battery, same as before, our Arduino, and here we have our pyroelectric sensor. We've got our 5 volts, our voltage out, and our ground hooked into the 3 different rows of the breadboard. So now we're going to place our 3 LEDs. We've got our yellow LED, our green LED, and our red LED, and each of those has the anode and the cathode in a separate row. And you can place them in a different order. It's just important that you hook each one up to the right pin that's written in the code, and we'll get into that a little bit later, but I've done them in yellow, green, red, but it probably makes more sense to do it green, yellow, red, like a traffic light would be. Now every time we use an LED, we can't hook it up directly to our pin on the Arduino, because it will put too much current through the LED and it will burn out the LED and it won't give off any light. So what we have to do is just put a small current limiting resistor in front of each LED, and we have put 220 ohms on each one here, running up to one of the legs. And it doesn't have to be 220 ohms, 330 ohms is a common one. You can use a little bit more, a little bit less, but just a low value, something like that. So now we have all our components in place and we're ready to start hooking things up. First thing we're going to do, same as last time, we're going to hook up both ground sides and both positive voltage sides of the breadboard. These are the buses, so that we can use power and ground on either side of the board. It just makes it easier to put everything together. Next, we're going to go ahead and hook up the battery. We're going to take the red lead, the positive voltage, and we're going to hook it to V in, or voltage in, on the Arduino, and that's going to power our Arduino and allow us to put voltage out of the Arduino to power our breadboard. And we're going to take the black one, the negative voltage or ground, and hook it up to the ground on our breadboard. Now we're going to connect together our Arduino and our breadboard. We're going to take our 5 volts out from our Arduino and plug it into our 5-volt bus on the breadboard, and we're going to take a ground out on the Arduino and hook it up to the ground bus on the breadboard. At this point, our battery, our Arduino, and our breadboard are all hooked up together and they have power. We can start hooking up the components. So the first thing we're going to hook up are the LEDs, each of those. The long leg, and it's important to make sure you get the long leg for this, is going to hook up to 5 volts on each of them. And then we're going to take pins 9, 8, and 7, and we're going to hook those up to the bottom of each of the resistors, and that will make the circuit through the pin, up through the resistor, through the LED, and then back into the breadboard. So we do that for each of those, and now our LEDs are ready to go. And finally, we're going to hook up our PIR sensor. We're going to take our red wire, which is our positive 5 volts, hook that up to 5 volts on the breadboard. We're going to take our black wire, which is our ground, and hook that up to ground on the breadboard. And then this yellow one, the middle one, is going to be our voltage out, and we want to read that on our Arduino, so we're going to route it up through to pin 2 on the Arduino. When all of these parts are together, our circuit is made. We're ready to load the code onto the Arduino and actually start it blinking. So let's talk about the code now. So now let's start talking about our actual code. First, we're going to define some values for our code. We're going to define PIR as the number 2. So anytime PIR is written, it's actually going to be the number 2. And then we're going to do the same thing for red as 7, green as 8, and yellow as 9. Next, we're going to define a couple more values. Whenever we use the word on, we're actually using the value high, and off the value low. So now that we've defined all of that, we can actually go to our setup loop under void setup and start sorting out how we want our system to run. First, we're going to set pin modes. We have 4 pin modes we're going to use here. red is going to be an output, green is going to be an output, and yellow is going to be an output. So if you remember, that means we're setting pins 7, 8, and 9 as outputs, which means we can turn that on and off. Whereas pin mode PIR, or pin mode for pin 2, is an input, so that means that pin 2 is going to be looking for a signal of 5 volts or 0 volts coming in. And then we're just going to set each of our pins, the green, red, and yellow, to be on or off to start with. We're going to set green as on, so we're setting green high, and then red and yellow are off or low. So that means when we start out, our green LED will be on, and our red and yellow LED will be off to start with. When we've done that, we're ready to move on to our loop. This is the part, as we said before, is just going to keep running over and over again until we turn off the Arduino or the battery runs out. So we're going to use an if statement here, and what we're looking for is if digital read PIR. So we're doing a digital read on pin 2, and what digital read is just looking if it has a 0 volts or a 5 volts coming into that pin 2. And 0 volts could also be written as 0 and 5 volts as 1. So what we're doing is if we get a digital read and it's 1 or 5 volts, we're going to go through this little loop. And if it's not 5 volts, it's just going to keep looking for it to turn to 5 volts and stay in the condition it was already in. So the first thing we'll do if we get that 5 volts from our PIR sensor detecting some motion is we're going to turn off the green LED, and we're going to turn on the yellow LED, and this will happen instantly. And we're going to stay in that condition, or delay it, for 3,000 milliseconds or 3 seconds. Once that 3 seconds has passed, we're going to go ahead and we're going to turn off the yellow LED and turn on the red LED. And we'll delay in that condition for 5,000 milliseconds or 5 seconds. Once that's done, we're going to turn off the red LED and turn the green LED back on, which gets us back to where we started in the first place. And we're going to delay 2,000 milliseconds or 2 seconds before we take another reading from the sensor. So every 2 seconds we're looking for motion. And it will just keep going that way. Every time you step in front of the motion detector, it will start this sequence of yellow, red, and back to green, and it will do that infinitely until we turn off the Arduino or the battery runs off.